Hello friends, M.A. Jackson once said, the beginning of wisdom for a software engineer is to recognize the difference between getting a program to work and getting it right. So getting it right is important than getting it to work. Today we present an overview of some software design concepts that provide the necessary framework for getting it right. Hello and welcome to our channel Ulhaskumar Gokhale for learning. The topic for today is design concepts part 1. So today we are going to see the concepts abstraction, architecture, pattern and separation of concern. Let us start with the agenda. First we'll have introduction to the design concept. Then we'll study the abstraction, then procedural abstraction, then data abstraction. Then we'll go for the software architecture. Then we'll study the properties of an architectural design, then different models of architectural design, then design pattern introduction, and then design pattern description, and then last topic, separation of concern, SoC. Lastly, we'll have the SoC summary. So let us start with the introduction. So a set of fundamental software design concept has evolved over the history of software engineering. There are some fundamental software design concepts which have evolved since they have been set by the software engineers. Now each provides the software designer with the foundation from which more sophisticated design methods can be applied. So they are used as a foundation so that we can apply more sophisticated design method. Then each helps you to define criteria that can be used to partition software into individual components. Then separate or data structure detail from conceptual representation of the software and establish a uniform criteria that define the technical quality of a software design. So the technical quality of a software design is very important, and to have a uniform criteria to define that, we must have certain principles or design concepts. Then let us go to the design concepts which we are going to discuss today. First we'll discuss the abstraction, then we'll discuss the software architecture, then design pattern, and lastly the separation of concern. So let us start with the abstraction. Abstraction is the process of hiding complex properties or characteristics of a software itself to keep things more simplistic. That means it is an act of representing essential features without including the background or details or explanation. That means we are trying to hide the complexities from the software itself so that it appears, say, easy or it is not complex. So we are having different levels of abstraction. So at the highest level of abstraction, a solution is stated in broad terms using the language of the problem environment. We are stating the solution in broad terms. Then at the lower levels of abstraction, a more detailed description of the solution is provided. We will provide more details about the solution at the lower level. Then at the lowest level, the solution is stated in a manner such that we can directly implement that in the form of source code. So that is the abstraction. Now let us go to the procedural abstraction. Procedural abstraction refers to a sequence of instructions that have a specific and limited function. So here we are concerned with the function abstraction or procedural abstraction. So it is nothing but a sequence of instructions and it will have some function. So the name of the procedural abstraction implies these functions, but specific details are suppressed. That means we are not giving all the details about the function. Only the name of the function is given. Then let us take example for this. For example, we have the word open for the door. Now here open implies a long sequence of procedural steps to open the door. So when you are opening the door, there we have different steps to open the door. For example, you walk to the door, reach out and then grasp the knob, turn the knob and pull door and step away from the moving door. So this is the long sequence of or steps to open the door. But here in the abstraction, we just say open. So this is for the door. Then here we should note that one set of operations can be replaced with another as long as the function implied by the procedural abstraction remains the same. So here we have taken the function open. So function is same, but the procedure or the steps, they can be different. For example, say if we have a door which is automatic, then the steps will change. So if the door is attached to a sensor, then accordingly we'll have to activate the sensor to open the door. So that is what is procedural abstraction. Then let us go to the data abstraction. So data abstraction is named collection of data that describes a data object. So here we are describing the data object with data abstraction. So in the context of procedural abstraction, now we have taken open. We can define the data abstraction called door. So here we are trying to have the abstraction for the data, that is door. So like any data object, the data abstraction for the door would encompass a set of attributes that describe the door. So for example, here we have door type, then swing direction, opening mechanism, weight, dimension, etc. So these are some of the attributes of door. So that we'll have to consider. Then it follows that the procedural abstraction open would make use of information contained in the attributes of the data abstraction door. So for the procedural abstraction, we'll have to consider the data abstraction door for the attributes. Then let us go to the software architecture. Now software architecture refers to the overall structure of the software and the ways in which that structure provides conceptual integrity for a system. So when we are having a system, the overall structure of the software and the way in which that structure provides the different components of the system, how they interact with each other. So that is nothing but the architecture. So in its simplest form, architecture is the structure or organization of program components. That is nothing but the modules. So the manner in which these components interact and the structure of data that are used by the component. So that forms the architecture. So one goal of software design is to derive an architectural rendering of the system. So this rendering serves as a framework from which more detailed design activities are conducted. So for a software, architecture is very much necessary. Then a set of architectural patterns enables a software engineer to reuse design level concept. So that's why the architectural patterns can be reused. Then let us go to the properties of an architectural design. So here Shaw and Garland, they describe a set of properties that should be specified as a part of architectural design. So the first is structural properties, that is the components of a system, for example modules, object, filters, and the manner in which those components are packed and interact with one another. That gives us the structural property. Then next we have the extra functional properties. So they address how the design architecture achieves requirements for performance, capacity, reliability, security, adaptability, and other system characteristics. So these are all extra functional properties of the software. That is reliability, security, adaptability. So these are defined with the help of extra functional properties. Then next we have the families of related system. So they draw upon repeatable patterns that are commonly encountered in the design of the families of similar systems. Now you might have studied different families for the microprocessor, microcontroller. So they have, say, some pattern which is repeated for the design. So the architecture will have that pattern in the design. So that is what is the families of related system. Then let us go to the architectural design models. So we have different representation for the models. First is structural model. So that represents the architecture as an organized collection of program components. So different program components, they are organized in certain way. So that defines the structural model. Then we have the framework models. So that is, it increases the level of design abstraction by attempting to identify repeatable architectural design frameworks, or we call it them as the patterns that are encountered in similar type of application. So if we are having similar type of applications, at that time we'll have certain pattern in them. Say, for example, you have, say, any web application or website, there will have a certain pattern in the website. Then next is dynamic model. Dynamic models addresses the behavioral aspect of the program architecture. So indicating how the structure of a system of configuration may change as a function of external events. That is what it is, a dynamic in nature. So functions will change with the external events. So that is addressed by the dynamic models. Then next we have the process model. So the process model focus on the design of the business or technical process that the system must accommodate. That is what the system is trying to do as a software. That is nothing but the process which the system follows. And then last we have the functional model. So it can be used to represent the functional hierarchy of a system. So different functions of the system, they are represented in a hierarchical way. So that is from one level to another level. So that is the functional model. Then next we have the design pattern. So we'll just have an introduction. A design pattern is a general repeatable solution to a commonly occurring problem in software design. It is a repeatable solution to commonly occurring problems. That is important. So design pattern is not finished design that can be transformed directly into code. It is not a finished design. It is just a pattern. So it is a description or template for how to solve a problem that can be used in many different situations. So here we have a documentation or description about the pattern, how to solve a problem in different situations. That is what is the pattern means. So the main idea behind using pattern is to provide documentation to help categorize and communicate about the solution to recurring problems. See, there are certain recurring problems which will occur in many of the software. So how to solve those problems? So that is done with the help of patterns. Then let us go to the design pattern description. So here Brad Appleton, he defines the design pattern in this way. A pattern is named nugget of insights which conveys the essence of a proven solution to recurring problem within a certain context amidst competing concerns. So let us see what is the meaning of this. See, a pattern is a named nugget of insights. Nugget of insight means what? It is a bundle of some insights. So it is giving us proven solution to recurring problems. That is very important. So the problems here, they are recurring in nature, and it is providing solution to those problems. And how it is providing it? With certain context among the competing concern. So whatever problems are faced by the software engineers and which are there to be solved with the help of certain pattern, so that we call it as the design pattern. So that is what is design pattern. So in other way, if you say, a design pattern describes a design structure that solves a particular design problem within a specific context and among forces that may have an impact on the manner in which the pattern is applied and used. How you are going to apply the pattern and use it, so that will have an impact on the particular design problem. So that's why it is just we are trying to solve the problem. The problem may be different from pattern which we have taken from another software, but we can use the same pattern and solve our problem. So the intent of each design pattern is to provide description that enables the designer to determine whether the pattern is applicable to the current work. So that is very important, whether the pattern is applicable to the current work, and then whether the pattern can be reused. So when you are able to reuse the pattern, that means you are trying to save the time. Then whether the pattern can serve as a guide for developing similar but functionally or structurally different pattern. So we can design a new pattern from a old pattern. That is what pattern description uses. Then let us go to the last topic, that is the separation of concern. So what is concern? Concerns are the different aspect of functionality that the software system provides. Then separation of concern, or SoC, is a design concept that suggests that any complex problem can be more easily handled if it is subdivided into pieces that can each be solved or optimized independently. So if we are trying to divide the complex problem into pieces, and the pieces they are independently operating, and we are trying to optimize those pieces separately, so that is nothing but the separation of concern. Then concern is a feature or behavior that is specified as a part of requirements model for the software. So first we have to understand what is concern. Concern is nothing but that is specified as the part of the requirement model. So accordingly, we have to go for the design of that. So by separating the concerns into smaller and therefore more manageable pieces, problem takes less effort and time to solve. So if you are having different concerns, so we are trying to separate the concerns into smaller and manageable pieces. So the efforts will also be less, and time to solve that problem will also be less. Then separation of concern is a design principle that manages complexity by partitioning the software into each partition which is responsible for a separate concern. So minimizing the overlap of the concern as much as possible. So we'll try to minimize the overlap of the concern. Then the principle is simple. Don't write your program as one solid block, because if you write the program as one solid block, it will become complex. So instead, you just break the program or code into chunks that are finalized tiny pieces of the system, each able to complete a simple distinct job. So that is important. So each piece of the code should do particular distinct job. That is what we have to follow. So let us go to the summary now of SoC. So separation of concern is the idea that each module or layer in the application should only be responsible for one thing and should not contain code that deals with other things. That is what is important. So when we are trying to write the code, at that time we should try to see that code has something responsible for one thing, not all different things. Because as you try to put different things into the code will become complex. Then Separating concern reduces code complexity by breaking up large application down into smaller units, and these units will be having certain functionality. And then last, separation of concern is manifested in other related design concepts which we are going to study. So that is modularity, aspect, functional independence, and refinement. So these are some of the concepts where we'll again come across the separation of concern. So this will be discussing in the next videos. So with this, we come to the end of this video. If you have any questions, you can contact me on Facebook, Twitter, Gmail, or Instagram. Then if you like the video, press the like button, share with your friends, and subscribe to our channel Ulhaskumar Gokhale for learning. So here you will be able to learn computer science, information technology, AI, and data science. Then don't forget to press the bell icon so that you get notifications for future videos on this subject, that is software engineering. Then thanks for watching. Have a nice day.